Cool. Okay. Thanks for those of you who have, joined us today. We've been there's a small team. We've been working on the Fabric EVM integration, and we're close now, or I would say we're pretty ready to make our first initial release. We want to kind of go through some of the main components of this release and then have a demo as well. So just as a quick intro, my name is Swetha. I work for IBM in the Open Technologies division. And then I also have my colleague Morgan, who'll be, I'll let him introduce himself.
Now or?
Sure.
Hi, I'm Morgan. I previously worked on Docker and Cube, and now I'm working with Swetha on this Fabric EVM. And hello.
Cool. Let me just give an outline of what I'm going to cover. Quickly go over some of the motivations, why this work has been done, explain some Ethereum concepts just to make sure everyone's kind of on the same page, then talk about how the integration has been done, and then we'll end with the demo, and then we should definitely have some time for questions. The motivations are generally associated kind of with the developer ecosystem and experience that has been created in Ethereum. Ethereum has kind of popularized the concept of smart contracts, and they've also created languages, Solidity, Viper, and those have become very popular, mostly because Ethereum kind of was the original, they coined the term smart contract, and because of that, many developers that are joining blockchain are learning those languages and are more comfortable writing contracts with those languages. So we want to enable them to continue being able to use those if they choose to on Fabric. The other thing is a lot of people who start developing, they create a lot of, they invest some time in it, they create some collateral, they have smart contracts, they have applications, and they're all geared towards Ethereum networks. And if Ethereum in the end does not suit their needs for, many different reasons, they're kind of locked into the the Ethereum network at the moment. We want to be able to give them an option to be able to migrate whatever they have existing onto Hyperledger Fabric. And then finally, there's a lot of tools that have been created for Ethereum. Some of the more famous or the bigger names are like Web3, which is a Node.js library. It makes writing applications that are interacting with smart contracts fairly easy. They have IDEs, like Remix, and since all this tooling has already been created, there's a pretty nice developer experience for some of these people who are used to that. It'd be nice to bring some of those onto Fabric. So with that, let me kind of start talking about some of the EVM concepts that we have. Ethereum has concepts of accounts. There are two types: EOAs, which stands for externally owned accounts. Basically, they are user accounts. They maintain balance, typically is what they're used for. In Fabric, since we are not going to be introducing any token as a part of this work, and accounts then don't really need to keep a balance of anything. User accounts are kind of made on the fly. Their address, basically the key to the account, is generated based off of a user's public key, which is the same kind of a concept in Ethereum. It's just that we're not storing any of these accounts in the ledger. They're just kind of made up when they're needed. The next type of accounts are contract accounts. Contract accounts are going to be stored on the ledger. They will have a key. The key will be generated based off of the user who created the contract, so their public key and a sequence number. Then from the contract, what it's storing is basically the EVM runtime bytecode. This is the code that the EVM needs every time a contract is invoked. So it kind of sets it up and says, okay, this is the contract. Let me set up the stack based off of using the bytecode that I've been provided. And then you can invoke transactions. So those contract accounts will be stored on the ledger, which is a difference from how Fabric does chain codes, as chain codes are stored usually on the file system. The next thing I want to talk about is gas. In Ethereum, or specific...
Before you move on, though, but the EOAs are recorded so if I create a contract and that contract is like an ERC20 or 722 or whatever, that's going to issue tokens and so forth, I would record in the transactions for that contract the EOA of the user that I'm issuing, either that I'm issuing tokens to, or trading between, and so forth. Yes? No?
Yes, you would, but that would be under the smart contracts data. It would not come under it. It would not be coming under the EVM CC. So from a Fabric side, unless you're specifically invoking the ERC20 contract, you won't have the account data.
Right. I just wanted to make sure that there was clarity around the fact that we do use those end user, the external accounts for purposes of accounting in the contracts themselves.
Yes, that will not change. So, for example, as Chris mentioned, if your contract is directly keeping track of account information, that stuff will be stored, and it'll be stored under that smart contract. Okay. So the next thing I wanted to talk about is gas. Gas is basically a unit that is used in the virtual machine, and you need to pay a certain amount of gas per opcode that you run. So the idea is you would provide each transaction with a set number of gas, and that costs you an amount of ether. So since there's a real cost involved, you are going to try to optimize your contracts and everything, because when you submit a transaction, there'll be hundreds and thousands of nodes that are running it, and to make sure that they're not wasting their resources, you have to kind of pay a transaction fee, and it's based on the opcodes that you're using. That concept is also to guarantee that your transaction ends, because if you run out of gas, your transaction is no longer run, and it kind of avoids having some for loops or infinite loops happening. The gas concept is kind of vital to the EVM, but we don't see at the moment. We've decided to make this a hard-coded amount. Each transaction is going to be provided with enough gas for a transaction to complete. We've made it a pretty high limit, and we don't foresee people running into out-of-gas errors. But this is something we could revisit in the future and make it more configurable if it seems like that's the feedback that we've received. Third point there is EVM message calls. So in the EVM, everything that it receives and sends is usually as a message. They follow a strict format, and it's kind of how the EVM understands what transactions are, what it should do. Even contract to contract invocations, it's a message that's being passed from one contract to another. And I'll kind of go a little more in depth into what those messages look like. The fourth thing is read current transaction rights. Now, this differs from how Fabric operates. In a chain code, when you write to a ledger, since you're not actually directly writing to a ledger, you're actually just creating a read-write set, you're not able to read the values that you would like to put into the ledger immediately after. You have to wait for the transaction to come in or to be added to the ledger. Because of that caveat, the EVM doesn't quite work with that system. We've taken care of this problem and kind of written a cache, so that way you're in it during a transaction. Whenever you write to it, you will be able to read it, even though it actually hasn't been put into the ledger at that moment. This is just a temporary, or this is just a fix for the EVM. It shouldn't affect any other kind of chain codes or anything. And then the last point on there is the Ethereum JSON RPC API. So this API is the API that all the Ethereum tools use to interact with Ethereum nodes and the Ethereum network and interact with smart contracts. This API we've decided to implement, at least partially, to enable some of the tools that we were mentioning before when we were talking about what we wanted to bring over from the Ethereum network, namely Web3, Remix, some things support we want to get into later is Truffle, which is also a very nice IDE used for smart contract development. So I'm going to go back to the concept of message passing. In EVM, there are basically three main fields that it looks at: the to, the from, and the data. The to is typically a contract address where you want to send the message to. The from will be who is ever creating the message. So it would either be the EOA if it's a user that's initiating a transaction. If it's a transaction to a contract to contract invocation, then the from would be the contract address of the originating contract. And then the data there is the actual information about what's being invoked. So for example, in a typical situation, it would be a contract invocation. The to would be a contract address. You would have a user account address, and the data in Ethereum world would be a function hash with the parameters that correspond to that function hash. Now, similarly, contract creation is also a message. It's a special kind. The difference is when you send the transaction in, you send it to the 0 address, and the EVM is able to recognize that and know that it needs to create a new contract account and store the data or the bytecode into that's associated to that contract in that account. So for us in Hyperledger Fabric, we've taken all that information and we've divided this into two pieces. One is the EVM CC, which is a user chain code. This is a wrapper around the Burrow EVM. We haven't done anything to the actual EVM, but we have put in, implemented Burrow interfaces, so that way we're able to have the EVM be able to talk to the stub. And previously in those message passing slides, I was showing you the to and the data. Those are the only fields that we're going to need, because when a user submits a transaction, we're already getting their public key, so we can get their account address from there. So the to and the data is the only required arguments into invoke. Then the second piece that we have is Fab3. This piece is basically a client. It uses the Fabric SDK Go, and it's not inside the Fabric network. And it's just a binary that implements some of the RPC API and enough of the API so that way we can use some of that tooling that we mentioned. As an example of how this would work, a user request, it'll be served by the RPC API in FAB3. Then using the Fabric Go SDK, it can talk to the API in the Pure, which will invoke the EVM CC. Then you can actually, with invoking the EVM CC, what it's going to do is use the state manager. The state manager is basically a Burrow interface that we've implemented, so that way the EVM can translate or the state manager translates calls from the EVM into calls to the stub. The initial step in a contract invocation would be getting the contract code, which would be in the ledger under the EVM CC namespace. And then after that, we would generate reads and writes. And then it's the same regular Hyperledger Fabric architecture. So the next part is the demo, but before we get there, are there any existing questions out there?
Yeah, this is a really good, Swetha. So just the one thing that's been sort of, I don't want to say bothering me a little bit is the EVM itself, because we've sort of forked it now, right? Well, I should say the Burrow team is essentially forking what we started with, right? And they're doing some refactoring.
Uh,
Am I right? I think.
Yeah. So the EVM piece itself, I would say it has been refactored. We're not going to put it into this release, but
Right.
the patches are already up there to move on to the new Burrow release.
Yeah, so that's the question I have, and again, maybe this is maybe for later, but do we expect that we should be able to sort of adopt what they've done, or are we effectively forking? That's, I guess, the question that I'm.
For the most part, we've been able to adopt what they've done.
Okay.
We didn't require too much of work on our end. Like in terms of a user who's using the EVM, they're not going to see any difference. And actually, you'll get a little bit more out of it. There are a couple pieces that will be breaking changes. One of them is the events that we've just put in. Unfortunately, it's going to change in the next one. So what's going to happen is the next release of the EVM will not be compatible with this one. Similarly with Fab 3. We could look into how to make it in terms of like, as long as you don't want things like events, you might still be able to do like a regular upgrade. But there are a few little things that people will have to be aware of if they're going from this release to the next.
Yeah, we should probably document some of, or at least sort of make that point.
Yeah.
Yeah, it sounds like there's a lot of dependencies there because Burrow also has to, as Ethereum moves forward, they have to continually maintain that, the changes on their side as well.
Yeah.
Yes. And because that is their main and only runtime, I think that I've been watching and they have been adding out opcodes pretty quickly. They've come to a stage where they've gotten the EVM in a good stage, so that way everything from now on is just kind of additionary, and it's like a few commands every now and then whenever the EVM spec changes, which is I think easier for them to manage as well. I have to commend Silas and their team. Even with their refactor, they did take a lot of the components and the pieces that we've already written initially and then use those. So we didn't have to write too many new interfaces or anything. We got to use the same things. We just had to pass in arguments at a different stage.
Okay.
Yeah. And I think they're kind of working on what is the best interface. So this is also feedback we can give them about what we think worked and what didn't work. And so they themselves become a little more stable. I'm not sure if that answered.
No, it does. I just think we probably ought to sort of, I don't know, maybe put a caveat saying we know some of this stuff is coming. There may be some breaking changes, caveat emptor kind of thing.
Yeah.
But documenting it is perfect because I think what's going to happen, there should be an expectation going forward that when Ethereum comes up with a new release and a new set of features, that those aren't automatically going to be available in Fabric at the same point in time. So understanding that pipeline, if you will, the change pipeline, I'll call it, gives you a sense that there is a timing delay there. So they can release something like Radon or whatever other changes they have on their side of the fence that would impact the EVM in some way. But you won't.
Yeah. So Jim, I think sort of yes and also no. I don't know about immediately, but certainly until such time that we're actually looking at doing some sort of true sort of seamless interop, I don't think that's necessarily going to be a requirement. I think we want to make sure that we are keeping up with the Joneses, but not necessarily with the same,
Right. You're not on the same version is the point, and that's fine. I'm not arguing that, but to your point, you just want to be aware that there is potentially a difference. That's all.
Yeah. We can make sure to add some notes both in the release note and the README just to make it clear where our compatibility is. So it's a little, so the people are not caught off guard.
Hi, Sweater. This is Leonard Hedwin. Just in listening to the conversation, and recently I heard about a 51% takeover with Ethereum based on its proof of work protocol. I just wanted clarity. I guess that does not affect us here because this
No.
EVM Burrows is riding on Fabric.
That's right.
Mm-hmm.
Okay.
We don't use proof of work or
Good.
stake for that matter.
Or
It's
stake,
just
right.
the EVM itself.
Yes, running on Fabric, which takes care of its Byzantine fault tolerance. Okay, protocol. Okay, great. Thanks. I just wanted that clarity. Bye.
Mm-hmm. No problem.
Could you explain how the contract gets installed?
Yeah. So let me go back a couple.
Or if you want to do that during the demo, that's fine.
I think Morgan will also cover it, but let me just kind of talk about in terms of the EVM or the CC, the EVM CC. So basically the idea is at a contract creation, when you do pure chain code invoke, as an example, the arguments you would pass in is the 0 address as the first one, and then the second address would be a compiled contract bytecode. So a Solidity contract, there are tons of compilers out there. You would pass in the contract and it would give you this, basically some data. That data you would pass in into the EVM CC, and then once the EVM CC gets it, it's going to skip this get contract code stage, and instead it's going to run it in itself in the EVM, and that produces another set of code. That second set of code is then stored into the ledger, so it just puts in as a put, and they create an account. I don't know if that clarifies. Maybe Morgan's demo will go into more detail and kind of answer your questions. But in general, it's the same kind of flow.
Yep. Okay. Got it.
Okay. And then with that, I'll pass it on to Morgan.
Hello, good morning. Happy time zone to you.
That's a good one.
Cannot start share. Okay, well, how do I, can usually share on this computer. Great.
You need to reconnect. Sometimes that happens to me too.
Okay, let me try that, I guess.
I don't know, work for me.
Just, okay. Hopefully somebody can like kick me off at the end. Okay, just let me center myself 1 second. Okay, so EVM chain code is a chain code. It is a user chain code, and I have installed it on basically the first network example, and it is installed and running on the Fabric network. Let's see if I can pull up my notes. Okay, so we can see the chain code is running. So the next step then is to attach the proxy to it, because the proxy speaks the JSON RPC API up to the user, which is what so again, this is basically an effort to bring the standard Ethereum developer experience to Fabric network, and so the standard Ethereum developers used to using the JSON RPC interface API, and so the Fab proxy is what serves that, and the let's see, that is not the right thing. So we've got a project here with that's the wrong tab. And so we've got a binary that runs that we compile, and that runs the Fabric proxy. And so and the Fab proxy uses the Go SDK, and that it takes the standard configuration as all the other SDKs. So if we look at the configuration in this directory, I have this set up. Basically, it takes configuration information to pass to the SDK to configure it in terms of what it should use. And it also takes a config file which has all of the network information in it to configure the SDK to talk to the Fabric network using basically standard Fabric APIs, the query the chain code, the system chain codes that return transactions and blocks on channels. And so then we run this, and it will look at these environment variables and start up. And very exciting. And now I need a browser. And so can we see the browser now?
Yep.
Yep.
And so this is basically the Remix IDE, which it's got a lot of Ethereum libraries installed in it, and it's basically a very pretty way of looking at all of the details of Ethereum contracts. And one of the things it lets you do is choose a compiler, and I need that one. But you can see it pre-populates some basic default contracts here. We're going to be using a different one, which I need to open because and so the contract I'm going to open is basically the default Solidity sort of example contract, which is the simple storage one. So it's an IDE, so I can make a new file, and we'll do simple storage Solidity, and we put that in there, and that's the basic thing. And if we set auto compile, it'll go. It has a copy. It'll download a copy of the chosen compiler and take the Solidity and run it through. And hopefully this compiles, and it gives you a contract. And so that's just the basic Solidity Ethereum developer experience kind of section. And then now we've got our Fab proxy running, which is serving the API. So now we've got to connect to that. By default, it runs basically an Ethereum EVM in the browser. But we want to connect to our JSON RPC provider, which here is called Web3 provider. And so we'll click that, and it'll say, do you want to connect? And we want to connect. And as we saw earlier from the configuration, I've got this running on locally 5001. So we go localhost 5001, and we click OK. And we can see that the Fabric EVM is now our provider. We can see we have an account, which is, as discussed previously, a sort of generated account from Fabric credentials used to connect to it. And we're connected as a specific user because we configured the Fab proxy to use those credentials. And so now we've got a contract, basic contract in here, and we can load that into the existing EVM provider and then run it. And so we do that by, we just basically, I've got this file open, so it compiles the file and shows me the, I can either deploy the contract or I can load in a previously existing copy. So let's deploy a contract. And you can see that it basically is sending the contract information down as that message, which is then going to go to the EVM in Fabric as that 2.0 address with the contract data. And that will instantiate the contract. And then Web3 helpfully reminds us that we have a copy of it deployed. And we can look at the details of it here in the little console inside the browser. And we see that we've gotten the transaction. This is a Ethereum copy version of the API that returns these transaction details. But we've populated it with the information that's necessary, and as we can see that the transaction hash here is this big number, and that is actually a Fabric transaction ID. And so you can go and use the standard tools to just look up that ID on this channel, and it will return the all of the transaction data that's associated with it, which for this is going to be basically storing the contract, the Ethereum contract data, the bytes at an address. So now everything's deployed, and it is a contract, and you can see it's very basic. It's load and store. So everything gets default initialized to 0. So this just does a query. But now if we want to store something, this will run this, and it has to go down, and then Fabric's going to get the chain code is going to get the call. It's going to run through it, generate its read sets, write sets, and then that just goes to Fabric, which will wrap everything up, create a transaction, create a block. And then eventually everything comes all the way back up, and we get the details on that. And now I know this says transaction mine, but there's no mining going on. But we have to the tools look for the confirmation of status as being mined. And so basically here that's equivalent to just the transaction being committed to a block and validated. So then if we do the get again query, you can see, okay, we've got our value that we set back. So then the other part of the other standard sort of environment that the Ethereum developer uses is a thing called Web3, and that is primarily a node library that basically does exactly the same kind of flow here, and we have to set it up. So we've got, where'd my mouse go? Okay, there it is. I'm going to just copy some stuff in here real quick because it's easier to do, but it's standard information. We're going to basically load the library, then we'll configure the library again to point at our local locally running proxy, and then we'll get a bunch of information about basically the library has a bunch of functions that we can use to interact with it, and we have the appropriate APIs defined that everything basically shows up correctly. And you can see that basically it's the same account. You can see 0BB281, and you can see in the Remix console same account number. So this is the same user. And so we can go into basically some Ethereum basics. If we go back to this, okay, so we have a compiler, we have a contract written in a language, and that compiles down to a different set of instructions, and those instructions are sort of pseudo assembly code that are Ethereum virtual machine instructions. And so another nice part of the Remix IDE is that we can go and look at all of the details of the contract now that it's compiled. And we can look at, okay, this opcodes section here is basically the Ethereum bytecode that you would write if you were writing assembly. If I can click this, and you can see that it's a bunch of assembly look-like intrinsics, and then you can see that the actual object bytecode is just the hex encoded version of the binary code that's what gets actually sent around and used. But from a developer perspective, we can sort of put that aside, and the more interesting things that we want to see are the ABI, which is the binary interface that defines what arguments. You can see we have our two functions. One of them is 0, one of them is 1. And so we can actually just take this information directly to our Web3 console and use that to interact with the contract without actually having to compile it or know the details of the bytecode. So let me make this bigger. So this is the Web3 console. We can see that, okay, so I've got an ABI, and so then I use that ABI to create a contract, simple storage contract, 1 ETH contract, and that takes the ABI, and then we actually need to make an instance of the contract because this is just sort of a representation of the contract itself. And we have an instance of it deployed already, so we can use that one. And like I said earlier, we've got this helpful thing that tells us the details of the contract, and so that's the contract address there. Copy that. And we go back here, and hopefully this works. Okay, so now we've got the same instance of the contract that we have already deployed, and we can interact with it as a normal function. Come on, caps lock, I don't need you on. We get the same value out. We can interact with the set. Everything's going on. It's creating the block. And so we have sort of consistency. Everything interacts the same. Another thing we can do is we can interact with it as a different user. So if I configure change the environment to, instead of be the org1 user, be the org2 user, and we run it again, you can basically do the exact same configuration as was done for the first user, and everything will continue to basically show up correctly. I've got a shortcut here. But we just, oh no, not that. Node counts. But you can see that we've got the original user and then we've got the second user. If we look at the transactions, we can see the transaction for the first copy is that. And if we take that and we can see that both users get the same transaction information, even though they're different users. They have the same overall EVM stack because it's the same chain code instance. So the last thing is important to the EVM developer is the instances of contract to contract, where you have one contract that needs the information and to call another contract. And so we will create a new invoker. And I've got the code here. And so the compiler is going to compile this and give us the details on it. And we can see that we've got both the interface and the contract itself. If we go back to run, we can see that we've got the invoke contract and we can deploy it. And we've got the previous address of it, which was this guy. And so we plug that in for when we deploy it. And again, goes over to the Fabric side, EVM runs it, stores, read writes it. And so now we've got a second contract, which is our invoke contract, which is hooked up to the original one. And it, gives the same results as the previous contract, because basically that's what it's doing in the background. It's just calling it and getting the values. And if we, set a value, then it comes out the other side. And that's pretty much the Ethereum developer experience we're trying to support. Questions?
Just one observation, Morgan. So for other people's benefit, the architecture that we have here with the proxy is really no different than what an Ethereum developer would have normally. They would have they would have to have one of two things. Either they would have a web-based Ethereum client running on some exchange, for instance, or they would have a local. They would have a client running locally. And so having the fab proxy where you either run it locally or maybe you have something running up in the cloud, Cloud Foundry, whatever, is really no different than what an Ethereum developer would experience. And the fact that we're talking that proxy then talks to Fabric isn't much different than the fact that whatever that client was, whether it's running locally or at some exchange, it's connected to the rest of the network. And so again, from a developer's perspective, there's, or even an end user, it's not really much different. Hopefully that makes sense.
Yeah, there are different providers that exist that people seem to like to write them in different languages, and then they'll also support only certain functions from the JSON RPC and then transform them into, more generic versions of the same kind of functions. So, yep.
And Swetha, maybe you want to just briefly talk about the conversations we've been having with the Truffle guys.
Yeah. So another piece of actually, Morgan, can I take over the screen again?
Yeah, I think I'm just gonna have to like kill Zoom to stop this unless somebody can force stop me.
Okay. I just had a slide for us to just talk about the current features, but I can, Truffle, let me just go over what happened there. So Truffle, like Remix, is an IDE. It's a Node application. It comes with a little bit more than what Remix does in some sense, where they give you ways to test out your contracts. It also gives you the ability to debug some of your contracts that you've deployed. So they have some nice features and everything, and they also use the Ethereum JSON RPC API in order to be able to talk to nodes or any kind of Ethereum network. So we've started conversations with the Truffle folks, so that way we can interact and see if we can collaborate together to get Truffle support into Fab3. So far, they're kind of learning about the project, learning where things are about Fabric, about the EVM piece as well. So it looks like that would be an exciting and new improvement. So let me do that. I want to say that we have a few different ideas on the Truffle support. So some of it is just initially to be able to use Truffle, like how we can use Remix, but then they have some cooler ideas about where they can take it further with some of the tools that they've created. Was there a question? Sorry. No. Okay. So let me just quickly go through the last of our slides. What do we currently have? We do support the deployment of most contracts. Some of the caveats there are, for example, ones like Arnaud mentioned, anything that requires you to have native tokens. Those are not going to work. There are as the contract compilers are improving or changing and things get added, of course, the newer items are not supported. We do have event support. So what this means is all the Solidity related events that get generated from one transaction, they're put together and they're sent in as a single Fabric event per transaction. We do allow contract to contract transactions, and we currently support Web3 Remix. Some of our limitations, as we've mentioned already, there's no Ether, no native token. Events from the Solidity compiler 0.5 do not work with the events that we just created. There are some EVM opcodes that are not implemented in this version. They are implemented in the next version. Revert is the one that I think most people will deal with. Some other ones are like return data size, return there's a few different ones there, but for the most part, if you are just doing some of the tutorial contracts, you should be fine. We do have some references. So we have our original design document that talks through some of the design decisions we made and why we've gone down that path. The actual chain code and Fab3 live at the Hyperledger Fabric chain code EVM repo. We also have a blog that goes through quite a bit of the same discussion that we've had today, and also kind of combines some of the information, but another piece of material. Yeah. Any other remaining questions out there?
No, but this actually does look pretty darn good as a starting point. And as you know, we're going to be on Fabric 2.0 shortly at some point, and I don't mean the next few days, but not too distant future. So that issue on the opcode thing looks like that won't be a significant issue either shortly.
Mm-hmm. Yeah.
So thank you.
Thank you.
Can you post the charts maybe to one of the Jiras? Which Jira is kind of the main one for EVM?
Sure, I can do that. Yeah.
Yeah. Okay. All right. Thank you.
Thank you.
Yep. Goodbye.